Alright, this is Mr. Anderson from Kellogg Community College. We're going to be looking at section 7.6, which combines factoring and solving for x. We want to figure out when 2x squared is equal to 7x plus 4. Now, the way that this problem is set up, it is right now unsolvable. And we're going to we're going to solve this without using the quadratic formula as well. So what we'll do is we're going to move everything over to one side and leaving this whole thing equal to the 0. So I'm going to subtract 7x and the 4 from the right side and move that over to the left side. What's that going to leave me is going to leave me a giant hole on the right-hand side, or 0, which is nothing. And then over here I've got 2x squared minus 7x minus 4, which is going to be a factorable trinomial. It's factorable because what we're going to do is use our factoring rules to solve for this. So the first rule is there anything you can divide from each of these three numbers? And there isn't. There's only x squared and x here. There's no x in this term. And 2 can't divide all three of these numbers. So unfortunately, we're stuck using some long-form factoring. And what I've done is I've actually gone through this problem earlier, because I'm assuming that factoring this problem isn't the real crux of the issue. The crux of the issue is trying to find out when it's equal to 0. So having done this ahead of time, this is my only choice, and the correct combo would be this number, the negative 4 and 1. Now, how I knew that is that what I did, I took my 1 and my 2, separated them with a plus, and then I'm going to multiply my 1 times 1 and my 2 times negative 4. Which gives me 1 plus negative 8, and if I add those together it gives me negative 7, which is the number in the middle. So, my 1 and 2 make 1x and 2x. Now here's the tricky part, trying to figure out where to plug in my negative 4 and 1. Well, my 1 has to be multiplied by the 1, so this has to go into the opposite place. When you do your O cable, there would be 1 times 1, and the I cable, 2 times negative 4, will be here. Now remember, this whole thing is set equal to 0. We took our original problem, which was finding out when 2x squared is equal to 7x plus 4, and we want to find out when this is equal to 0, or when it hits the ground. So what we'll have to do is go x minus 4 equals 0, and 2x plus 1 equals 0, and find out when it does hit the ground. Now the first problem is pretty easy. It's going to hit the ground at 4. In the second problem, we're going to subtract 1 from both sides, so 2x is equal to negative 1. Then we're going to divide by 2 on both sides. X is equal to negative 1/2. So this graph hits the ground at 4 and negative 1/2. Also, I will tell you that if you plug those back into the original problem, it'll actually hold true. And I'll prove that to you right now. So I'm here to prove that 2x squared is equal to 7x plus 4 for the answers of 4 and negative 1/2. So I'm going to plug in the 4. So 2 times 16, because that's what 4 squared is equal to 7 times 4, which is 28 plus 4, and 2 times 16 is 32. 32 is equal to 32. 4 is one of my 2 correct answers. Now I'm going to plug in the 1/2, negative 1/2, excuse me. Now this one's a little trickier. I tend to know my fractions pretty well, so it won't seem so hard. But with a graphing calculator or calculator, you could figure this out too. 2 times negative 1/2 raised to the second power is 2 times a fourth, because negative 1/2 times negative 1/2 is positive 1/4. And then here we have 7, which is going to get multiplied by negative 1/2, so it becomes negative 7/2 plus 4. Now, what you'll do here is do a little bit of multiplication. So 2 times 1/4 is going to be 2/4. Looks like I have an attack cat coming into the picture here. How you doing, Maggie? Come on, girl. Come on. Oh, there we go. There we go. Thank you, Maggie. So 2 times 1/4 is going to be 2/4, which is 1/2. So this left side is 1/2. Negative 7/2 and 4. This is negative 3.5 if you convert it in the calculator, and negative 3.5 plus 4 is equal to 1/2. So, yay. It works. It works. So thank you to all the KCC students who emailed me for questions this weekend. And thank you to my lovely wife who's given me time to set this up and helped me out with this. And thanks to my cat Maggie. All right, take care.